Welcome to Innoy Science. In high school physics, we have read that momentum equals to mass into velocity. Simple enough, right? But here comes the twist. It has been experimentally proved that light has momentum, but it has no mass.
According to formula of momentum, P equals to mv, if mass is 0, then momentum will also be 0.
So what's going on in here? Before understanding that, let's first start with what momentum actually is. Well, momentum is nothing but ability to exert force on something.
Suppose you throw a ball pointing towards a wall. When it hits, it delivers a push on the wall. This push itself is momentum.
Momentum can also be seen in a passive way. It is a measure of how much difficult it is to stop a moving object. If something has a momentum, it always tries to resist any changes to its motion.
That's why to stop the ball I mentioned needs some force to stop. Higher the velocity or higher the weight of the ball, higher will be the momentum.
Momentum is clear so far, I guess.
Mathematically, it is described as P equals to mv.
But this formula fails in two conditions.
Condition 1. In case of massless objects.
For example, light. At the very beginning, I said that light has momentum, but it has no mass.
So this equation is not valid in here. Condition 2. For objects with very high velocity near the velocity of light. Why? Suppose I add more force on the ball. So what will happen? Momentum of the ball will increase, but mass of the ball must remain same. So its velocity will increase.
Now think, if the force is huge enough, then the ball at some point will reach to the velocity of light or even more than that.
Suppose the ball weighs 1 kg. So the P equals to mv formula says that if we apply 3 into 10 to the power 8 Newton force on that ball for 1 second, the ball can achieve the velocity of light. That is 3 into 10 to the power 8 meter per second. Now see, if the force is more than this value, the velocity will definitely be more than this value, that is more than the velocity of light.
But to go beyond the speed of light is impossible and against the law of nature.
So P equals to mv equation does not stand right in here.
So what will be the right equation here?
Well, Einstein said that the right equation will be P equals to gamma mv. Gamma is Lorentz factor, which is 1 divided by square root of 1 minus v square by c square, where v is the speed of object and c is the speed of light. Now let's assume that the ball has actually achieved the velocity of light. So v equals to will be c, and v square divided by c square will be equals to 1. So Lorentz factor will be infinite. So in this case, where we assume that the ball has achieved the velocity of light, the momentum of ball will be infinite. What does this mean? This means that we need infinite amount of force to achieve velocity of light.
To apply infinite force is actually impossible.
So yeah, here it makes a sense that to reach the speed of light or beyond it is actually not possible.
See, P equals to mv equation shows us that a ball or anything can reach this velocity of light. But P equals to gamma mv shows us that it is never possible for anything with mass to reach the velocity of light or beyond than that. So P equals to gamma mv equation makes a real sense, because to reach at the velocity of light for an object having mass is actually impossible. So did we learn wrong thing in our school? Absolutely not.
For the objects with velocity much less than light, the value v square divided by c square is very small, negligible, near about 0. So the Lorentz factor becomes 1. So here momentum becomes P equals to mv.
On our earth, all the objects we see like car, stone, a sheep or anything moving has velocity much less than that of light. So far our discussion was about the objects having mass.
But even P equals to gamma mv, this equation also says that if mass is 0, then momentum is also 0.
So what's happening for light? Let's again remember high school physics. Light is an electromagnetic wave.
An electromagnetic wave consists of an electric field and magnetic field perpendicular to each other. Suppose a light wave propagates in z direction. Its electric field oscillates along y-axis and magnetic field oscillates along x-axis. Now, if the light wave falls on a table, its electric field will make the electrons of the table oscillate along the same axis of the electric field, that is, along y-axis. From the property of magnetic field, we know that magnetic field applies force on a moving charge. So, the magnetic field of light will exert a force on the oscillating electrons of the table. And what will be the direction of the force? Well, it will be perpendicular to both the electric and magnetic field, which is along z-axis. In other way, in the direction of light wave.
So light can exert force. And at the very beginning, I said that momentum is nothing but an ability to exert force. Light can exert force. That's why light has momentum. No mass required, end of story. So what will be the right equation for massless objects?
According to Einstein's theory, it will be P equals to E by C. E is energy that the wave carries. C is speed of light. Recap. For objects with velocity much less than light, P equals to mv. For objects with velocity near the velocity of light, P equals to gamma mv. For massless objects, P equals to E by C.
I hope concept of momentum and its relations with velocity and momentum on the shadow of relativity is clear so far. I hope you guys liked my video, and if you liked it, please subscribe. See you in my next video. Bye-bye.